This lab is a series circuit analysis. To begin, we'll be going over the materials. First, we have 2 light bulb sockets. Then we have 2 light bulbs, 1 switch, 2 wires, a multimeter, and a 9-volt battery. Throughout your lab, keep the switch open and do not close it until the circuit. Once again, this is the multimeter. So for the purpose of this lab, we're going to turn the dial to 200 ohms. Next, to illuminate the display, we're going to hit the blue button. So our next step is we're going to test the resistance of the switch in the light bulb by using the black prong and pairing it with the black plastic, and the red prong pairing it with the red plastic. However, do not touch the plastic, touch the metal inside. Alright, so to record your answer, hit hold. 1.8 will be the number for light bulb 1. So once again, this is another light bulb socket. However, this time it uses a spring. So to use it, you have to lift the spring and insert the metal part of the prong. And our recording for this resistance for light bulb 2 is 5.3 ohms. Now we will measure the voltage of the battery. Turn your multimeter to 20 volts. Then, with the metallic part of your prongs, apply to the metallic part of the battery. In this video, as you can see, the wires are crossed. Do not do that yourself. Our recording is 8.14. So this is what a completed series circuit looks like. We have our switch, we have our socket and our light bulbs, and we have a battery, and then we have our wires. Now, as you can tell, we've attached the wire to a metal part. However, be careful with the caps. You have to make sure that the metallic part of the wire is not touching the plastic part. So you have to unscrew the plastic and then re-screw it back on to tighten the wire. So now we're going to go ahead and test the voltage at 20 volts. Now this is the only time where you will close the circuit. So now quickly take recordings. This for light bulb 1 is 2.32. For light bulb 2, the answer is 3.30. And the voltage for the battery is 6.11. Now quickly open the switch. Alright, so this is the worksheet for part 1 of the lab. As you can see up here, we have the resistance readings for light bulb 1 and light bulb 2. And over here we have the voltage readings for the battery, which was the actual, what was printed on the battery versus what we record on the multimeter. Alright, so for part 3, it asks you to draw a diagram of your series circuit. So here I'm using I'm using the symbols for each component. So here I have the switch, these are the light bulbs, this is the battery, and then these ones are the wire. Alright, so down here for number 4, these are the readings of the voltage when the series circuit was turned on, when the switch was put down. So for number 5, it asks us to verify if the voltage drop on each component is equal to the total amount of voltage supplied by the battery. So we have, as you can kind of see here, I color-coded it just to make it a little bit more clear. So VT, which is this, so 6.11 equals V light 1, voltage for light 1, which is 2.32 volts, plus VL2, or for our recording, 3.30 volts. So these do not equal, but they are close. So 2.32 plus 3.30 equals, so VT in this situation will equal 5.62, which is close, so we're going to say that this is pretty valid reading. Alright? So, down here it asks us to calculate the equivalent resistor. So, we have over here, if you can tell, the resistance we measured up here, so 1.8 ohms and then 5.3 ohms. So all we're going to do is add 1.8 ohms plus 5.3 ohms, which is going to give us an answer of 7.1 ohms, which once again is pretty close to our answer, so that's going to be a pretty good number. Alright, and so for the last problem on this page, it asks us to calculate the current flowing through the circuit. So the current is going to equal the voltage, this right here, 6.11, all over the resistance, which is 7.1. And if we type that into our calculator, we get 0.86 amps. For part 2 of the lab series circuits, we will need alligator clips and a resistor, and all of the materials we previously used. It is required in this lab that you know how to read a resistor. So it is a little difficult to see in this video. However, the first 3 lines are going to help us to determine how many ohms our resistor is. So we have brown, black, black. So the first 2, brown means 1 and black means 0. So we have 10. And then the other black line indicates how many zeros will be added. And since black is 0, we will only have 10 ohms. And as you can also tell, there is a gold strip. And the gold strip indicates the tolerance of plus or minus 5%. Now we will test the resistance of the resistor. First, you need to turn your multimeter to 200 ohms. Then illuminate the display. Then you want to take your prongs and apply them to the metallic part of the resistor. Try not to touch the paper and have a firm hold. It's recording, it's 10.2. This is what a series circuit looks like with a resistor. So if you look down here, we've attached the alligator clips, attached the resistor using the alligator clips to the wires. Now we're going to set the multimeter to 20 volts. We're going to close our switch and we're going to quickly measure the voltage of our parts. So our light was 1.29 volts. Our resistor is 2.12 volts. And our other light is 2.63 volts. And finally, our battery is about 6.53 volts. Now, once again, quickly open. So this is the worksheet for part 2 of the light bulbs and resistor and series circuits lab. So the first thing that we have to do is to identify and write down the color code resistance, which was shown previously. So in our video, we recorded 10 ohms with a plus or minus 5%. So this tells us if a little bit, like the recording we should get on the multimeter is going to be either 5% more of 10 ohms or 5% less of 10 ohms. And so we get a resistance with the multimeter of 10.2 ohms, which is correct. So next we have to draw a series circuit diagram. So from here we have the switch, we have the two light bulbs, we have the resistor, then we also have the voltage, and then in here is just the direction of the current flow. Now down here, after we recorded the this is the voltage of each component in the diagram when the switch has been turned on. So for light bulb 1, we got a measure of 1.29. For light bulb 2, we got a measure of 2.63. For the battery, we got a voltage of 6.53. And then for the resistor, we got 2.12. So next, it asks us to verify the voltage drop on each component. So we have to then add light bulb 1 plus light bulb 2 plus the resistor. So we have 1.29 plus 2.63 plus 2.12, okay? So we have to use this resistor of the voltage we recorded when the switch was on. So in total, we get VT equals 6.04 volts. Now, next, it asks us to calculate the equivalent resistor. So we have RT equals light bulb 1, which is 1.29, plus light bulb 2, which is 2.63. Now, plus the resistance. And now we're going to use the resistance that we recorded from the multimeter, which is 10.2 ohms. So right here, it should be 10.2 ohms. And we should get an answer of 14.12 ohms. So next, we have to calculate the current flowing through the circuit. So we have our VT, which is 6.04, divided by the resistance, or RT, of 14.12. All right, so when we put that into the calculator, we get 0.43 amps. All right, so the next part of this worksheet is to compare the results from part 1 with the results we calculated in part 2. So part 2, VT, we got 6.04. For the resistance, we got 14.12. And for the current, we got 0.43. All right, so now we have to look. So does resistance and the current increase or decrease from part 1 to part 2? So if we look closely at it, yes, the resistance increases from part 1 to part 2. So the resistance increases. And if we look at the current decreases. Now, when you're doing a lab like this, you have to make sure since the resistor is being added, we know in the first lab we didn't have resistor. So when the resistor is being added, we know automatically that the resistance should increase from not having resistor to having a resistor. And therefore, and since there's another component being added to the diagram, the current which is flowing is going to decrease to 0.43 from 0.86.